Hey everyone, this is Mr. Ahlers. I am looking at your weeks. So we have 1, 2, 3, 4, 5 more weeks to go. I got some good news for you. Um, we have this week this is the last week of new instruction for us, and then we're going to review next week and we'll have a test. And then I actually decided that we're not going to have a final, and we're just going to work on the IA for these 2 weeks. So you'll be uploading things, and then I'll be giving you some feedback, and that'll kind of help give us um, a head start for um, the fall, and then do that. Um, so we're gonna be doing 19B, 19C, 19D. I may have to do 2 videos. We'll see what happens. I have about 45 minutes to do the videos. So, um, so I wonder if you guys can hear Sonya or not. Okay. So we did do the areas between um, a function and the x-axis. So remember, you just took an integral from the region, from the bounds, and then you did integral from 0.25 to 4 of the value, and then you calculated it. So now we have 2 functions. So this time we want to find the area between 2 different functions, and I want you to look at this region. I always draw a rectangle here. I always draw a rectangle, and this right here is the top, and this is the bottom. And remember, it's always top minus bottom. So this one's nice. You just have to do the integral of f of x minus g of x from a to b. A lot of times you'll have to solve set the equations equal to find those intersection points. So we can see immediately that if y equals f of x equals 0, and this is g of x, you would just do 0 minus g of x, from a to b. If it's 0, you can just bring this negative to the front. And technically, area below the x-axis is negative. So that's why there would be a negative g of x integral from a to b. So let's get to practicing some problems. So bounded by the x-axis is the first function, y equals 0. And the other function is y equals x squared minus 2x. So we will need to graph the x-axis. I'll draw that in blue. And then we need to graph this. This is x minus 2. Because we have x equals 0 and x equals 2. So we have intersection points at 0 and 2. And it looks like it opens up. So it goes something like this. I have no idea how far down it goes. I just guessed. And we want to find this region here. So because it's below the x-axis, it should be negative. Our a value is equal to 0, and our b value is equal to 2. So we want the integral from 0 to 2 of 0 minus x squared minus 2x. Guess what students forget to do? There should be that negative sign. So we can do it 2 ways. I'm going to do from 0 to 2, bring the negative out to the front of x squared minus 2x dx. Integrate x cubed over 3 minus x squared from 0 to 2, and you make the whole thing negative. Plug in 2, you get x8 over 3 minus 4. Minus 0. 8 over 3 minus 12 over 3 minus 0. Which is negative 4 over 3 minus 0, so that's 4 over 3. So as I was talking about, like, I made a mistake. This, when you do top minus bottom, it negates the fact of it being 0. So, like, even though it's below the x-axis, because I did the top function minus the bottom function, you'll get a positive integral, which is why we have 4 over 3. If I would have done the integral of x squared minus 2x from 0 to 2, then x cubed over 3 minus x squared over 0 to 2, then you would have gotten the negative 4 over 3. But because we did top minus bottom, it like does the work for us to make it positive. So let's give you a better one. So we have x plus 2 and then we have a function, and it's x minus plus 2, x minus 1, x equals negative 2, and x equals 1. So I'll graph that. Negative 2 and 1. I actually don't know if that's the right spot. The way I'm going to do that is x plus 2 equals x squared plus x minus 2, x squared minus 4, x equals 4 squared, x squared equals 4, x equals plus minus 2. So it did work out. So this is b and this is a. So now with the integral from, so top is the purple function, so x plus 2 minus x squared plus x minus 2 from negative 2 to 2. This time, because I don't have the 0, I'm going to simplify it. I have negative x squared minus 4 plus 4 from negative 2 to 2 dx. So it's negative x cubed over 3 plus 4x from negative 2 to 2. Plug in 2, you get negative 8 over 3 plus 8 minus, you get 8 over 3 minus 8. So those are, that becomes negative 16 over 3 plus 16. That's 48 over 3 plus 16, negative 16 over 3, which equals negative 32 over 3. Positive 32 over 3. And just remember, it's always top minus bottom. Find the total area enclosed by the regions enclosed by x-axis in this function. So x squared plus 2x minus 3, x minus plus 3, x minus 1. So x equals 0, x equals negative 3, and x equals 1. If I plug in 2, you get 8 plus 8 minus 6, what's a positive number? Well, some of us are finished now. 16 minus 6 is 10. So 2, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to guess it goes like this. Okay. And we have this function as y equals 0. Now it's broken up into two regions. So this time you have to do two integrals. You have to do top minus bottom for that one, and then you have to do top minus bottom for this one. So the first integral is from 0, -3 to 0 of x cubed plus 2x squared minus 3x, and then plus from 0 to 1 of 0 minus x cubed plus 2x squared minus 3x dx. So I'm going to integrate that. X to the fourth over 4 plus x cubed, 2x cubed over 3 minus 3x squared over 2 from 0 to -3 plus negative in front. And you have x to the fourth over 4 plus 2x cubed over 3 minus 3x squared over 2 from 0 to 1. Plug in 0 turns into 0, plug in -3. I'm just typing this into a calculator. I don't think you can see it. So I got -11.25. That doesn't make sense. -3 over 4. Oh, it's 0 minus that. So then that equals 11.25 plus negative, plug in 1/4 plus 2/3 plus 3 over 2 minus 3 over 2. 1 divided by 4 plus 2/3 minus 3 divided by 2. Is -7 over 12. So you add those two together. -45 divided by 4 plus -7 divided by 12. 71 over 6. Super. Pretty gross. So you can do this using the end fire, but you just have to do separate intervals. So illustrate the curve, the graph, sine of x and sine 2x. New graph. I think if you hit, I'm going to do sine x and then wrench graph entry function sine 2x. So those are graph. Identify each curve on the algebraic coordinates of A. Identify each curve. Alright, so here's the graph of the two functions. I'll put that in here for you. A is this point. Here. C1 is, this is C1, this is C2. So to find A, we gotta set them equal to each other. Sine of x equals sine 2x. So to solve by hand, I'm gonna write this as sine x cosine x. That's 2 plus sine of x. Bring it to the other side. 0 equals 2 sine x cosine x minus sine of x. So we have sine of x times 2 cosine of x minus 1 equals 0. Sine of x equals 0. And then cosine of x equals 1/2. And cosine of sine of 0 equals 0 at 0. And pi. And this one, cosine equals 1/2 at pi over set 60 degrees, so pi over 3. So area is equal to pi over 3. And find the total area enclosed by the two regions. So there were two areas, these two. So you can do two integrals. You can do from 0 to pi over 3 of sine x minus cosine 2x plus, and from pi over 3 to pi of sine 2x minus sine of x. So this is negative cosine x plus cosine 2x over 2. So it's negative cosine 2x over 2 plus cosine of x from 0 to pi over 3, from pi over 3 to pi. Plug in pi over 3, get negative 1/2 plus, that turns into 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2 over 2. Cosine 2 pi divided by 3. Yeah, negative 1/2. And then plus minus cosine of 0 is negative cosine of 0 is 1. So negative 1 plus cosine of 0 is 1, so plus 1/2 plus cosine of pi is cosine of 2 pi is negative 1 over 2 plus cosine of pi is negative 1. minus cosine of pi over 3 and negative 1/2 over, I think it's negative 1/2 over 2 plus cosine of pi over 3 is 1/2. 1/4, negative 1/4, negative 3/4 minus plus 1/2 plus negative 1/2, 3 over 2 minus 1/4 plus 3/4. Hey everyone, I'm sorry, I made a mistake here. This one should have been 2x minus sine x, and this one should have been, I should have switched these. So I'm going to make this pi over 3, and then this should be from pi over 3 and 0. So fix all that. I'm really sorry, everyone. So sine of pi is negative 1 plus negative 1/2. No, 1 positive minus pi over 3, negative pi over 3 is 1/2, so negative 1/2 plus 2 pi over 3 is negative 1/2 over 2. That is 1/2, and then again plus 3 over 4, which equals 1/4. And then this one over here is negative 1/2 over 2 plus 1/2 minus this one zeros negative 1/2 plus 1, which is 1/4 plus 1/2 minus 0.75 plus 0.75. Pi over 3, negative 1/2 times negative 1/4. Cosine of negative 1/2, so that's 0.75. And then plug in 0. Cosine of 0 is -1 half plus 1. Let me start over. Sorry, everyone. Okay, the first integral is from 0 to pi over 3 of sine 2x minus sine x plus integral from pi over 3 to pi of sine of x minus sine 2x. This integral is negative cosine 2x over 2 plus sine x. This one is negative cosine x minus plus sine 2 plus 2 cosine 2x over 2 from pi over 3 to pi. Within pi over 3. That is negative 1/2 over 2 plus. That should be cosine 1/2 minus pi and 0 and negative 1/2 plus cosine of 0 is 1. So you get 1/4 plus 1/2 minus 1/2, which equals 1/4. Okay, that one's done. This one over here, cosine of pi over negative cosine over pi, that's negative 1 plus, so 2 pi is 1 over 2 plus minus pi over 3 negative 1/2 plus negative 1/2 over 2. So that's 3/4 plus is positive 1, so 3/4, which equals 6/4. I think when I type that in, wrench, bounded area, 2.25. Cosine of pi is negative 1, that's 1. Cosine of 2 pi is 1/2. Oh, this is 1 point. This is 3 over 2, which is 6/4, which is then now 9/4, which then equals 10/4. Jeez. I'm really sorry. I'm going to try to edit out that part. Kinematics, 19C. So the curve area illustrates cosine 2x and cosine x squared. Identify each curve. This one is cosine 2x, and this one is cosine squared x. Determine the coordinates of A, B, and C. Well, this is 0. B, so it's 2x. Normally this is 2 pi, but this is pi. This is pi over 2. And then this is pi over 4. And that's 3 pi over 4. Show that the area of the shaded region is pi over 2 units. So I want the integral from 0 to pi of cosine squared x minus cosine 2x. I think cosine 2x has like a special rule. So this right here is equal to 1 minus sine squared x minus cosine 2x from 0 to pi. And this turns into 1 minus 1 half minus 1 half cosine 2x minus cosine 2x, which is 1 half plus 3 over 2, no, minus, plus 1 half cosine 2x, the integral from 0 to pi dx. So it's 1 half x minus 1 half sine 2x all over times 2 from 0 to pi. So plug in pi over 2 minus sine of 2 pi, 0. That's just 0 minus, plug in 0, 0 over 2 minus 0, sine of 0, 0, minus 0, so pi over 2. It's a little bit easier. So that's integrating between two functions. Always remember top minus bottom. Okay, kinematics, distances from velocity graphs. So before we could always go from displacement to velocity to acceleration, but now we can go backwards. And these are pretty fun. So if you know the velocity function, you want to find the total distance traveled, you can do the integral of velocity. And then remember if it's below the x-axis, put the negative right. So the velocity time graph for a train is illustrated in the graph alongside by the total distance traveled by the train. So what you could do is take the integral of this function. This is f of x. Take the integral of f of x from 0 to 0.6, which is just equal to the area under the curve. So 30, 40, 50. So what's 0.1 times 50 over 2 plus 0.2 times 50 plus 0.2 times 30, and this region is plus 0.1 times 20 over 2 plus 0.1 times 30 over 2. 25, 2.5 plus a 10 plus 0.5. 60, 6 plus 10, times 0.1 is 1, plus 15 times 0.1 is plus 1.5. So 18, 19, 20, 21, 22, 23, 23 kilometers. I think this one is 4. So this was the first region. Second region, 0.2 times 3, 6. It's 21. I think I was 9. 18, 19, 16, 17, 18, 19, 20, 21. Sorry. Terrible counting. So you remember that displacement function is equal to the integral of the velocity function. So find the total distance traveled. Sometimes you need to know the initial spot. So the particle moves in a straight line with the velocity function blah. Answer the problem without using a calculator. How far does P travel in the first 4 seconds of motion? So let's run a sign diagram that set v of t equal to 0. So t squared minus 3t plus 2 equals 0. So t minus plus 3, t minus 2, t minus 1, t equals 1 and 2. So on your sign diagram, 1 and 2, we can test it. I'm going to plug in 0.5, positive. This looks like it's going to be positive, negative, and positive. So that means it changes directions at these two. So for the first interval, from 0 to 1, t squared plus 3t plus 2 dt plus, and then from which is plus, technically it's from 1 to 2, but because it's negative, I'm going to put 2 to 1. That makes it positive. So t squared minus 3t plus 2 plus, and then you go from 2 to 4 of t squared minus 3t plus 2. So integral is t cubed minus 3t squared over 2 plus 2t from 0 to 1 plus from 1 to 2 plus 2 to 4. So plug in 1, I think you get 5 over 6 minus 0 plus plug in, this is from 1 to 2, and this is 5 over 6 minus 2/3 plus 16 over 3 minus 2/3. And that should equal, I think it's like 15 over 16 over 3. Sorry, 17 over 3. Because this is 14 over 3. It is 1 over 6. Which is 6 over 6. Just 1, 2, 3. That's the total distance traveled. Find the displacement after 4 seconds. That's when you just do the integral from 0 to 4 of t squared minus 3t plus 2 dt. And then you get t squared cubed minus 3t squared over 2 plus 2t from 0 to 4. And you end up getting 16 over 3 minus 0, which is 0, which you get 16 over 3. So slightly more, but it makes a difference. The particle is initially at the origin and moving to the right at 5 centimeters. So the initial position of the origin, so S of t0 is equal to 5. So keep that in mind. Accelerate to the time according to blah. Sorry. V of 0 equals 5. So find the velocity function of the particle.
Oh, okay.
So the integral from 4 minus 2t dt, so that's 4t minus t squared plus c equals 3t. So 5 equals 4t minus t squared minus 5.
Okay. Yeah.
So 0 minus 0 squared plus c equals 5. So then 4t minus t squared plus 5 equals v of t. Sketch the graph. It's quadratic, going down t squared negative t squared minus 4t plus 5. And it's negative t and t. So t equals 0. Plus minus negative t squared plus 4t minus plus 5. So t equals 5 and t equals -1. So then your sketch is going to look like this. For the first 6 seconds of motion, determine the displacement of the particle. So the integral 0 to 6 t squared negative t squared plus 4t plus 5 dt. Negative t cubed over 3 plus 4t squared over 2 plus 5t from 0 to 6. Plug in 0 to plug in 6. You should get about 30 minus 0 plus 30. The total distance traveled. You want to do the integral from 0 to 5 of negative t squared plus 4t plus 5 dt. And then this is from 0 to 5 plus integral from normally you should do from 5 to 6, but because it's negative, I'm going to do from 6 to 5. Plug in 5, you should get 3/4 of 3 plus, and then when you add this one is 34 over 3, this is 10 over 3. There's 44 over 3, which is approximately no. This is 100 over 3, so it's 110 over 3. It's approximately 3206.66. The displacement function for a particle moving along a horizontal line is given by S of t, blah, where t is measured in seconds and s is measured in meters, and the velocity of the particle at time t. So integral of S of t, oh, take the derivative. So it's v of t equals t minus 2t. Find when the particle is moving right, v of t equals 0. So this is 2. So t minus 2t equals 0. T equals 2, 1. Plug in 2, negative, plug in 0.5, positive. Moving right from 0, moving left from draw motion particle for plug in 0, you start at 8. 4, 5, 6, 7, 8. That's starting because when I plug in 0, I get 8. And I'm going to go right, plug in 1 second. So 8, 10, minus 1, 9, 0, 1. And then plug in 2, 8, 12, plug in 3, 8, 6, 14, that times 5. Right definitely definitely goes to find the particle exchange and displacement and the total distance traveled in the interval from 0 to 4. So the first one, displacement is from 0 to 4, 8 plus 2t minus t squared dt, and then the displacement for the first 4 seconds is the integral from 0 to 1, 8 plus 2t minus t squared dt plus the integral from, so it's supposed to be from 1 to 2, but because you want to do backwards, you put 2 to 1, 8 plus 2t minus t squared plus from 2 to 4, but because it's going backwards, I think you want from 4 to 2 to give you a positive 1. And you type this in your calculators and you get your responses. Zero, 0 to 1, I think it was like 8 plus 2t minus t squared plus 2x minus x squared x. That's the total displacement. And this one is from 0, I don't know, that's the total displacement. Plus 2, 1 plus 4 to 2. If you plug in 4, you get 8 plus 8 plus 16 minus 4 times 4 squared is 16. Let's redo this measurement. Plug in 0, you get 8. Plug in 1, you get 9. Plug in 2, plug in 4, you get 0. I need to go from 2 to 4, or 1 to 4. But then it should be from 4 to 1. Make no 18. 18. 18 plus, which is 19. So definitely goes is from 0. That's what I'm doing now. I'm taking the derivative, the antiderivative of the displacement function. It should have been 2 minus 2t, 2 minus 2t, 2 minus 2t, and then there you go. That will get you your 2 answers. Type into your calculator and see what you get. And you go from 0 to 4 of 2 minus 2 dt. There you go. And you get the integral from 1 to 2, 0 to 1 of 2 minus 2 x dx. Enter. And you have the integral from 1 from 4 to 1, total of 9. So you got a total of 10 on the other, and then displacement is -8. There we go. velocity v and particle moving in a straight line given by law. Find the acceleration at time equals 1. Take the derivative to t. Put in 1, a1 equals 2. And the initial displacement of the particle. Initial displacement of the particle is 12. Find the expression for s. Take the integral of t squared minus 9 to t cubed over 3 minus 9t plus c. Plug in 0 and say equal to 1. You end up getting 1, c equals 1. So then s of t equals t cubed over 3 minus 9t plus 1. And the distance traveled between the time 2 seconds and 8 seconds. So then you want the integral from 2. First, let's graph this. T squared minus 9. T squared minus 9. So you want from 2 seconds to 8 seconds. So I think it's going to be totally fine. Of x t squared minus 9. So you get t cubed over 3 minus 9t, 8 to 2, 8, 64, 216. 512 over 3 minus 9 minus 8 divided by 3 minus 167. The velocity function given long, find the acceleration at time equals 3. So the slope of the line at time equals 3. That their slope is of 8, 8 over 4 is 2 meters per second squared. Write down the time intervals in which the particle is traveling to the right from 0 to 4. And then from 15 to 16. And the total distance traveled. So you want to find the area of this, plus the area of this, plus the area of this. So that's 4 times 2 over 2 plus 4 times 8 over 2 plus 6 plus 2 over times height, which is 2 over 2. So 4 plus 16 plus 8, 28. And we're going to stop here and save volumes and revisions for next week. So we might move back your test. So your homework is day, I think it's 102 and 103. And then we're going to save all your revisions for the following week. Sorry for the mishmash question.